Mm, Hi, today we're going to talk about DynamoDB and let's understand how what DynamoDB is and how um, it helps as a database service, and what is the key role of the DynamoDB in the range of databases which are out there. No, DynamoDB is basically a NoSQL database, and it is fully managed by AWS. It provides a consistent single-digit millisecond latency and independent throughput and storage scaling. It also supports both document and key value data models. It does the automatic data replication across three facilities. It also provides read consistency with eventual and strong consistencies. So uh, within the DynamoDB, the data is partitioned. So uh, with partitions, data is stored and retrieved um, at any amount. So it also provides auto scaling, and it provides HTTPS access with IAM authentication. So it is also fast and consistent and provides consistent performance as it scales as well. And it also provides a downloadable developer version. This is just a database technology timeline. When it started, early, um, it it started with ledgers and some records, drums, file systems. Then we moved to RDBMS, and recently we have come with NoSQL databases. But why is that? If you want to understand why RDBMS was found, or why it was done, it was basically because to save spaces in the in the data. Earlier, data was storage was very expensive, so data should have, or it was a must to be normalized. But NoSQL takes a different approach altogether. So now the storage has become very cheap versus CPU computation. CPU computation is still expensive. So um, with RDBMS, what happens is storage um, is less, but computation capacity is always more. And with NoSQL databases or NoSQL approach, uh, you would find a denormalized data set or access patterns. So data, uh, the storage would be more, and the computation within the database, within the uh, NoSQL database would be minimized, or it would be less compared to RDBMS systems. So this is just a comparison of how the data was in 2010 and how it is today. So the systems which were producing 1 TB data way back in 2010, now it is almost producing 6 petabytes. So what it means is it's not the same system, but system which is doing equivalent operations are producing more data, and we are using these data to do many things like analytics and uh, many operations around the data. So uh, the systems which are built to around 2010 were producing more data points or more data. I mean, some data where at the present the same kind of systems are producing more data. So this trend is will continue to grow over time. So we are expecting more data to be produced, and our databases are uh, you know database options has to be open to such huge data storages. So we need to understand that uh, there are two different variants, right? RDBMS is SQL variant, and DynamoDB is NoSQL variant. How they weigh in, in the features. So let's quickly understand how it works. So basically, SQL is optimized for storage. NoSQL is optimized for compute. SQL is normalized. It's relational, and NoSQL is denormalized and hierarchical. So you get it can NoSQL can SQL can handle ad hoc queries, but NoSQL should have instantiated views where we could access those views and retrieve the values. Otherwise, if you are trying to do ad hoc queries, it would be very expensive. So SQL scales vertically, which means that you need to add more CPU to handle the workloads. But NoSQL scales horizontally because these are placed in distributed systems, and you could add cheaper systems in parallel. SQLs are good for OLAP, and NoSQLs are good for OLTP, and it can scale at any level. And SQL, we choose SQL or RDBMS when we have a boundary, or when the data is bounded. What it means is when we can think of employee management, where employee has there will be certain set of employees, so the data is bounded, but there are certain data which are unbounded, right? So for example, GPS data, or let's say a car rental system's GPU or GPS information of the um, car would continuously keep adding to the database, and you never know how many what is the end for that, or what is the boundary for that data, right? So there can be thousands of cars which are producing thousands of data points every second, right? So um, NoSQL database are built for such scale. So if you see the access patterns, this is how it is structured. So uh, uh, you can see that it is linked, it is normalized, and data has a relation with tables, with many tables. But if you see the NoSQL data's pattern or access pattern, you find most of the data is fit inside a single table with hierarchical approach. We'll see more about the hierarchical approach and some of the benefits of it. Before, let's understand some of the core components of DynamoDB. So the first core component is table. So it has two uh, subcomponents. One is item and attributes. So any row or any entity constituting all its attribute will be considered as an item, and attributes are part of the item. We can have a primary key for to identify uh, the item. So the primary key can be broadly divided into partition key and sort key. So primary key can be either of these two. So partition key and sort key are also called as composite key, and just partition key is also called as a simple key. And we also have secondary indexes, which are you know part of the core component of DynamoDB. Secondary indexes has there are two secondary indexes: global secondary index and local secondary index. We'll learn more about it in a moment. So DynamoDB also has something called as DynamoDB streams. So what it does is it captures data modification events in DynamoDB tables. So whenever a write event happens in the DynamoDB table, the information is captured in streams. They are ordered set of events, and they are in near real time, and the stream logs has lifetime of 24 hours. Let's understand the data model of DynamoDB. So we talked about tables. Tables are collection of items. So in this pictorial diagram, each row is an item, and each item contains collection of attributes, and each uh, attribute can be a name value pair, where it can be a scalar value, it can be numbers, it can be strings, it can be multi-valued, it can be a set, uh, it can be string or number set, and it can also be a document. It can be a JSON document, it can be a list, it can be a map, it can be anything. So attributes um, are also optional in nature, so you don't need to have it is not a must have for the item. The most important of uh, item is or a mandatory part of item is partition key. So partition key is accessed based on key value, and basically partition key determines the data distribution within the DynamoDB distributed system. Sort key is an optional entity, and this uh, optional sort key gives different relational models that we have defines different relational models. It can be one to n, it can be n to n relationships, and basically it enriches the querying capabilities. So how does it enrich the querying capabilities? We will see further. But if you want to understand, you know, at a very high level, so when you add a key in a sort key, you could filter it, or you could sort it based on, or you could retrieve it based on some of the filters here. Here is an example. You could say if the sort key begins with, let's say, customer, or begins with order, then we could retrieve all the items which are beginning with order. So there are many filter options that you could uh, use, and um, you know that would enrich your querying capabilities. So let's understand the partition key. And um, basically, partition key is a hash type key, and it is made of one attribute, and that is required for all items which are placed in the table. So each partition key should be unique, and it is uniquely identified uh, by that item. So it has to be unique, and uh, partition key is used for building unordered hash index. So that, inside the partition, the items are not ordered by the hash index. So table is partitioned for scale as well. So here's an example of how record items are placed. So these boxes are partitions. So a hash function is applied on um, on the primary key, and a hash is generated. Based on the hash value, the item would be placed in the uh, respective partition. Also note that primary key cannot be changed or modified, and these once these items are put inside the buckets, they begin to grow inside the partition, and uh, it can be ordered only using sort key. So let's see how it's done. So when you use SDK, you would see these terms hash and range. So basically, it means partition key and sort key. So these primary key are made of two attributes. So these are also called composite keys, and these are required for all items. Once you define um, the sort key, it has to be present to order it, or and also uniquely identify um, the item. With Within an unordered hash index, data is sorted and arranged by range or sort key. So both, when you create a composite key, then what happens is, you know the combination of hash key and range key, that is partition key and sort key, becomes the um, identifier of the object, or item is uniquely identified by both of these keys. So there is no limit on number of items per partition key, except if you have a local secondary index. So there would be 10 GB limit. Mm, we'll see why and how it is, so how we can handle that. So any partitions are partition any items are replicated in three different availability zones or three-way replicated. So if you see the example ID2, if you take ID is equal to 2, it is placed in three different replicas. So you have a good chance of um, not losing the data, and that means high availability and also reliability. This also gives us the challenge of consistency, and we'll see how we can achieve that and how actually the data are placed and all that in a moment. So again, at a very high level, let's understand the table structure. Basic whole thing is a table. We create items. A table consists of items. There are many items, and item consists of attributes, primary key and attributes. As a simple primary key would have just the partition key, it wouldn't have a sort key. So a composite primary key would have both partition key and sort key, and attributes are the ones which are part of the items. So these are optional. Uh, Anything can go inside these partitions, inside these um, attributes column. So let's understand the API actions which are available. So what are the APIs that we could use, and what are the effects of it? So there are item based actions. So item based actions are uh, you know writing, updating, and deleting. And for item based actions, you have to provide entire primary key, uh, whether it's for if you have composite primary key, then you have to provide both partition and sort key, or if you have a simple primary key, you have to provide the partition key. So there is also a query based operation that you could do. So on those circumstances, you must provide partition key, and sort key is not mandatory. And you could there is also another operation, that is a scan operation. Basically what it does is it will examine every item in the table and returns you the result based on your request. So there are some anti patterns or not best practices where people will use a scan and use a filter in it. So filter expressions, so those are not recommended because your whole table has to be scanned, and those uh, operations are expensive. So it would be okay when you have a limited data or less data. When the data grows, um, your scan operation becomes very expensive, and um, it is recommended not to use scans. And we have a different approach to solve um, these problems. So let's say in this table we have year, and you want to retrieve the data based on the year. Then how would we solve it, right? So let's see how we can solve that. So there are this can also be achieved through using scan and filtering it by the year, but that is never a good approach to do that. So mostly scans are used when you're doing ETL job, or when you're moving the data to one location, uh, or uh, basically you're exporting the data, or uh, you are using the scan operation on one item, let's say scan and get just one item out of the scanned operation, and that would be probably on a sparred index. So we'll see what sparred index is, but uh, we should use scan at a very minimum. Okay, let's move to secondary indexes. So secondary indexes are basically for uh, capabilities where we want to retrieve the information, or we need to retrieve the items which is not based on primary key, uh, uh, either it is simple or composite primary key. So if whenever we have a need of such access pattern, then we would create a secondary indexes. So basically, the requirement of using primary key limits the access patterns of the table. So we basically use alternate key structure to query or scan the operation. But using secondary indexes, you cannot use get item operation. So get item operation is cannot be used on secondary indexes. So there are two types of secondary indexes. One is local secondary index, and other one is global secondary index. So local secondary index can be used on the table with uh, composite primary key only, and it is with the same hash key but different range key for the table. So what it means is uh, you have a partition key and a sort key. Partition key would not change, and the sort key would change. And those circumstances, when you want to have partition key same as the you know earlier partition key, or partition key when you don't want to change a partition key, and when you want to change only the sort key, then you would use local secondary index. So global secondary index is exactly opposite to local secondary index, right? So what it does is it gives you an opportunity to create your own simple key, or you could create your own composite key, which are not um, same as the primary key. So let's see how it works in a bit. So some of the basics of secondary index are, so there is no uniqueness requirement. So in in primary key, the requirement is that the partition keys has to be unique all the time, right? So for the base tables, uh, the partition key has to be unique to be constructed inside the partition as well. But when it comes to secondary indexes, you could choose any attribute as part of the key, and it doesn't have to be unique as well. So what happens with that's the reason, you since there is no uniqueness, you will not get to use the get item operation on secondary indexes. And it is also that not all items, not all attributes of the secondary indexes are required. So if you have 5 rows, and if you have selected, let's say, address as secondary index, and address might not be part of all the 5 items, but you can still promote it as secondary index. So there is a index limits per table. You could use 20 global secondary indexes and 5 local secondary indexes. So why they have a limit, we will understand in a bit. But uh, earlier there was just 5 global secondary indexes. They have increased it to 20 global secondary indexes. So to understand some of the projected attributes of secondary indexes, you need to understand what it really means. So it is something like we specify which attributes you want to uh, retrieve with the help of the index. So it plays a very important role in your indexing, because the values that you want to index, or the attributes that you want to index, uh, really plays a major role in your uh, cost. So the thing is, there are three attribute projections that we can use. We can say keys only if you want just the keys, and we could use all. And when you say all, the full item would be indexed. And when you say include, and you could add certain attribute names, only those attributes would be projected in the secondary index. So you have to be very careful while choosing your projections. DynamoDB charges based on the amount of data indexed. So projecting all might result in excess charges. Okay, but it is also, when you start, it's a clean trade-off between what you're selecting as projected attributes and what you're not, right? So if you're not choosing the right set of projected attributes, then what happens is you might have to uh, you know send another request or another query to retrieve those attributes. So there instead of one query, you might have to do two queries to retrieve the second attribute. So it's a it's like a review, and you know uh, change that, and again review it and update it. So it goes on. So um, you might have to change quite often on the projected attributes. But let's see some of the restriction what happens with secondary indexes, that is with local secondary indexes and global secondary indexes. So in uh, local secondary indexes, um, so you can apply local secondary indexes only with the table which has composite primary keys, which means that the table should have a sort key, and only if you have sort key you could provide an alternate sort key instead of the existing one, right? So, and also you must provide the requirement at the time of table creation. So you cannot add the local secondary index after the table is created, or now the existing tables. But it is not so with global secondary index. It also has 10 GB limit per hash key. So what it means is it includes the size of items in the base table, plus combined size of items in all local secondary indexes. So if you are choosing the projected attributes, uh, then you have to basically you have to judicially choose those projected attributes. So you also have a consistency option when it comes to local secondary index. You could choose whether it to be a strong consistency or eventual consistency. So strong consistency will consume more capacity. It's almost double the capacity, uh, but it might be the right choice in some situations. So they share the throughput with underlying base table. So uh, they don't have a separate throughput capacity. When it comes to global secondary index, the it has got its own separate throughput capacity. So you could provision the read and write capacity units for the global secondary index, and this is always eventual consistency. It provides only eventual consistency. It doesn't provide uh, strong consistency, and there is no partition key size limit. When it comes to local secondary index, you have a 10 GB um, partition key size limit. So you don't have that limit when it comes to global secondary indexes. And you could use it on any table uh, which are out there. Um, so what it means is the table doesn't need to be doesn't need to have only uh, partition key, and or it could be partition with sort key. So the table could have simple primary key or composite primary key. It could be used on any kinds of table, and you can also use with any key schema, as I told. So it could be uh, as I told, simple or composite key schema. So what is sparse index? To understand sparse index, so it's basically when not every item contains the attributes you're indexing, and only items with the attributes matching the key schema for your index will be copied into the index table. So you might end up with fewer items in the index than in the underlying base table. So as and when you add or remove any item, or when you update, sorry, when you basically update an item, um, on that update there might be addition or removal of that particular attribute, and during the updation, after the updation, immediately this sparse index would be updated based on the change in the attribute. So when do we use this sparse index is basically when, let's take an example of order system where um, let's say someone has placed an order, and order status is placed, and you want to index based on um, the order status is placed, and you would get the list of, you would get the index of all the orders which are in place status. And uh, let's say warehouse guys are um, the providers. Let's say Amazon is trying to cater to your order placed, and it could use scan in this case, because it is let's say it is having a um, less number of items, because this is just a theoretical approach. So they would get a finite list of or a small list of items which could be used for catering that orders which are placed in place status. So sparse index are basically used in those scenarios where you get a very small fewer items when compared to the underlying table. So when do we use LSI or GSI, right? If basically LSI can be modeled as GSI, so there is you know there is no restriction for that. But if the data size in the item you know collection is more than 10 GB, then you have to go with GSI. But if you are looking for strong consistency, then you have to go with LSI. So this has to be thought through before creating the table. So if you need strong consistency, then you might have to uh, think through before you even create the table, right? So that is the one of the drawbacks or challenges of NoSQL. So you might have to think um, when it comes to DynamoDB, you might have to think what is the structure that you are going to build within the table so that you can efficiently retrieve the data. So how do GSI update works? GSI is Global Secondary Index works is it's basically asynchronous. So when clients sends an update request, the table would respond back saying that it will update, and the asynchronous update process starts in the background. And whenever there is not enough capacity, write capacity, then the table write might be throttled, and it might not you know write the response immediately. It might not write the update immediately. It might take some time to write inside the global secondary index. Then eventually it will be written, but within that time or before it even writes into global secondary index, if the client um, requests the data on the global secondary index, then it would return a stale information or stale item. So as I mentioned, the key concepts are the two: selecting a primary key whenever you are modeling a table. Selecting the primary key is the most important thing, and whenever you're selecting a primary key, you have to think uh, oh, within your table what are the large number of distinct values that are produced within that uh, set of entities that you have. And items are uniformly requested and randomly um, distributed. So what randomly distributed means is underlying partitions are created in such a way that the items are distributed randomly. So the key examples, a good example of partition key and bad examples of partition key. Let's see that. So if you are using status as a partition key, that's a bad example, because status can be a finite set and they are not always unique, and any data that goes in would be overwritten. So these are bad approaches, or these are bad attributes to be used as primary key. So the good approach, good attributes would be customer ID or device ID or any ID for that matter. Or you could create your own hash or UUID to be used as primary key or partition key. So when you're selecting a sort key, think of it as a model which has 1 is to n relationship or n is to n relationship. So if you have a customer and order, if customer and order is having 1 is to n relationship, then uh, order is a best option for a sort key. And a sort key also gives you an efficient pattern to query with multiple entities. So you could actually save multiple entities as part of sort keys. So what it means is, let's say if you have, uh, you know, for example, let's say we have country, um, state, and city, and let's take these three. So country, state, and city. You could use state. You could combine state and city into one, and create a and combine these multiple entities into one sort key and use that for retrieval. And there are, as it says, there are selective patterns where you could use to uh, find the items by saying, let's say if it begins with the you know this particular sort key, then retrieve that item. So there are many selective patterns which you could use. So you could use date range, you could use in between, or is equal to, not equal to, many things. So some of the examples of a sort key would be order items, things like that, and basically where you have hierarchical relationships. So let's understand what that hierarchical relationship means. So yeah, here is an example of the example which I spoke uh, earlier. So there is country, state, city, and also office. So we have created a composite key um, called location, and uh, composite sort key called location. We have clubbed all of the information related to state, city, and office within one key, and we have used our own uh, you know delimiter. It could be anything. So we have considered hash here. In this case, you could consider any special character or anything to delimit different keys. But these are, when you see such approaches, these are very much different from, RDBMS concepts, relational concepts, where we create um, multiple tables and we join those tables, and uh, we could easily structure those tables. But when it comes to NoSQL, you have to think through this and uh, construct these sort keys and primary keys. Uh, the reason we need to do this is because at the end of this exercise, we would be achieving uh, fast access to these records. So ultimately, we are saving computational costs in retrieving these items. So that is the ultimate goal while we are using NoSQL approach. Basically, this would reduce the query complexities. So what selective queries really means is that we could say before, let's say, we could use this delimiter and say begins with New York or begins with one NY. Select country is equal to USA and location which begins with NY, and you would get all the items which are part of New York State. So that is an example for retrieving items using composite sort key. So there are some of the tenets of NoSQL data modeling. So we need to understand the use case, and we need to understand whether it's OLTP, OLAP, or it's addition support system, DSS. So if the use case is OLAP, that is analytic processing, we shouldn't consider it for NoSQL at all. So mainly it is not preferred because analytical processing is takes a different approach um, altogether. We would see that why in the next class probably, but uh, we would mainly focus on OLTP kind of approach, or kind of applications which supports transactions or addition support. So basic, yeah, online transaction protocol and online analytics protocol. Oh, uh, yeah, that's not a protocol. I'm sorry. Online. Yeah, I think it's processing. I'm sorry. It's processing. It's yeah. It's processing. I am sorry. Yeah, it's processing. Yeah, it's processing. Uh, Transactional processing. OLAP is analytics processing. Analytical processing. Yeah, yeah. I'm sorry. I said it's a protocol. It's a processing. So another item is we identify the access patterns. Basically, we define the queries and write patterns. Uh, you know, looking at the read and write workloads. We also data model it. We avoid relational design patterns and use only one table for constructing the whole application. So what it means is, um, if you have one application service or a team of for one team or for one purpose, you could use one table. You should ideally use one table for all that, for all of your applications services. So it reduces the round trips and simplifies the access patterns, but it complicates the design, and you have to think through uh, a lot while you are uh, you know selecting the primary keys, uh, and you have to uh, identify the access patterns prior to creating the table. So let's understand DynamoDB streams a little bit. So DynamoDB stream is ordered flow of information about changes of items within the DynamoDB table. It captures information about every modification that is done to the item in the table, and it is basically captured in time ordered sequence of item level modification, and it is stored up to 24 hours, and the application can access these logs in near real time. They are encrypted at rest, and streams helps ensure that records appear exactly once in the stream, and records appear in the same sequence as actual modification to the item. So basically, these DynamoDB streams uses Kinesis stream underneath. So it gives the same kind of you know high availability or reliability what Kinesis can provide. But note that logs are stored up to 24 hours only in case of DynamoDB stream. So you could use or you could integrate DynamoDB stream with AWS Lambda, and uh, what it does is if you have to integrate it with it, then you have to provide two permissions, particularly two permissions for Lambda. One is invocation role and another one is execution role. So invocation role is basically for Lambda to get invoked as and when the stream is generated. So basically Lambda, um, AWS Lambda goes and picks, polls for the stream whether um it is present or not. So when it keeps polling and when it finds a record in the stream, um, it will start its execution. But if you want to access the record in the stream, then you need to have an execution rule for that DynamoDB stream. So ultimately you end up having you need to have two kinds of roles. One is invocation role and another one is execution role for a DynamoDB stream. So within the stream, there are different stream view types which are there, which says in this example, I have taken one record item. Sorry, record ID is one and name is Alice, and I have changed the Alice to Allison. So what happens is when you update this particular item, a stream is generated, and the entire uh, you know image of the item is returned. So what happens is if you want, you could set a view type to be old image or new image, uh, or if you want both old and new image. Images are basically items which which are part of the stream now. So you could select uh, either you want the old which was updated or new one which is updated too, and you could also just say um, uh, I need only keys which was updated, so you could use that as well. So these are the you need to specify what kind of view type you need when you're creating the stream. So basically, if you want your application to access the streams directly, other than, let's say, if you don't want a Lambda to be used, and if you want some EC2 instances to uh, access the stream, what you could do is you could use Kinesis client library, and also you might have to use DynamoDB Stream Kinesis adapter to access the stream's low-level API. So you could basically access the streams from any application. So with streams, you get a capability of you could you have number of applications with DynamoDB stream. You could use many of the AWS services along with uh, DynamoDB stream and uh, DynamoDB stream and Lambda, and you could build messaging applications. You could build many applications around it. But one of the you know required, or one of the fine possibility is cross-region replication. So what happens with this is, if there is any update in one table, you could use the DynamoDB stream to replicate uh, the same data with multiple locations. So basically, you could use the streams to uh, uh, copy the changes that has happened uh, within the table, and you could use it as a disaster recovery, or if you are trying to cater to a different uh, set of users which are part of different location or region, um, then you could use this cross-region replication. So basically here we are using we can use any open source library, but we could also use global tables. So global tables are provided by AWS, where it provides a similar a multi-region architecture. So it could be active multi-region architecture or active passive architecture. So uh, basically the difference between I'll tell the difference between active and active passive very briefly. So active means both regions are masters. So if you are trying to cater for two different regions at the same time, just to solve the latency problem, to provide low latency between two regions, let's say uh, one in Singapore and one in Europe, then if you have customer base in both these regions, and to provide the low latency, you could use the global tables with active configuration. Or if you want to just handle the disaster recovery, then you could use the active passive architecture. So basically DynamoDB tables are DynamoDB global tables uh, are used for global distributed users, and this will eliminate the of the previous action what we are trying to do. So we'll have to we'll have to use a uh, open source framework, where we have to manually um, read the streams and put it into the different um, or DynamoDB region tables. Rather than that, we could just use global tables. So global tables also consists of multiple replica tables. So basically, you could uh, save these your content with multiple regions that you select. So all of these replicas are will be treated as one single unit by the DynamoDB table. So DynamoDB can be accessed using VPC gateway endpoint as well. Let's say you have EC2 instances, and you want to access the DynamoDB table within the network, or you have a EC2 instance which is accessing DynamoDB table, and there is no need for you to go uh, the internet route, because if you are taking the internet route, there will be one is there will be cost involved, because there is some data transfer between the internet, and the next thing is the latency. So since you are using the internet route, you would consume the latency would be more. So the best option is uh, you know use gateway endpoint. So gateway endpoints are supported for Amazon S3 and Amazon DynamoDB tables. So upon basically upon creation of VPC endpoints, um, of these gateways, what happens is record is added in your route table, and all requests are routed through those um, route table. So there are I have added a link here to uh, check how to create VPC endpoints for DynamoDB table. Please go ahead and check it out. So let's say you have a requirement where you, though the DynamoDB table provides you with single digit millisecond latency, you are looking for let's say microsecond latency, and you have a requirement for um, you know your application where uh, the applications is read intensive or read heavy. So in those scenarios, we could enable something called as DynamoDB Accelerator, which is basically a caching service for DynamoDB table. It is enabled you in in memory performance. It's fast in memory performance, and there are three main core scenarios when you would use DynamoDB Accelerator. So basically, the first reason would be if you want to use you know the core scenario would be in memory cache, so where you could achieve the uh, microsecond latency, and uh, this DAX would be um a managed service, hence you don't need to create your own caching service um, inside your VPC. So these are also read heavy, and if you are looking for bursty workloads, then it's best to enable DAX, which would actually yield you um, better cost performance instead of you over provisioning the read capacity units. So this feature that is DynamoDB Accelerator caching service is counted on cost. So you have to pay for this service, but mostly this would be beneficial for read heavy workloads. So this is how uh, DAX clusters are placed. So it would be part of your VPC, and it would run within your VPC. Your application should or your EC2 instances should have a DAX client to communicate with the DAX cluster, and you will have to communicate with these API requests to uh, get the to communicate with the caching service of DAX. And if, let's say, if for reason your um, request is not cached, or your item that you're looking for is not cached, then your item would be the request would be forwarded to DynamoDB. So it is basically an managed service for DynamoDB cache, you can say. So let's say you know the difference between one of the core difference between SQL and NoSQL was till now. Uh, NoSQL had, or it wasn't providing ACID or transactional capabilities, but now with DynamoDB, they have added the ACID capabilities or transactional capabilities. So, what let's see what or how it provides. So, you can achieve this with basically two APIs. There are transaction write APIs and transactional read APIs. With transactional write APIs, you could group multiple put, update, delete, or any conditional checks that you have as part of the actions and execute it, and either only on the success or failure of all of these items, um, your data would be written inside the into the DynamoDB. So with transaction write items, you get synchronous update or any of the write operations, and you could automate the rollback. So it is basically the rollback is automated. Sorry. So up to 10 items within the transaction is supported. So it also supports complex conditional checks as well while performing these transaction write APIs. You could also, same features are also supported by transaction get items. Basically, this is a read API. These are provided at no additional cost, but to perform this transaction, you know, there will be two um, additional, request which will be used. So to perform this transaction, there will be one to prepare the transaction and one to commit the transaction. So there will be two separate underlying read or writes for every item in the transaction. So if you are, let's say there are 5 items that you are using within the transaction, so there would be 5 into 2, that is 10 additional, request or reads or writes which will be added as part of the transaction API. So it would turn out to be expensive, but it would give you the um, ability to achieve the transactional or ACID properties. So let's deep dive quickly about how the items are stored and how the database is, DynamoDB is structured. So as and when you request for get item within the network, it would go and reach the request router. Request routers are stateless entities, so they would check the your policy, and it would run through the authentication system. If it passes, then it would hit the storage nodes. So storage nodes consists of a lot of distributed solid state drives where all your data are placed. And since this is SSD, you could they could achieve uh, single digit millisecond latency. So when it comes to put item, could see that the requester would hit the storage node leader. There would be something um called as a storage node leader, which is the primary node, and this primary node would communicate with the other storage nodes using heartbeats. So this heart symbol basically depicts heartbeats. So till the heartbeats are alive, which is happening every 2 seconds, suppose. So so with every this primary node would save any put item initially, and immediately it will write into the second available storage node. And once the second storage node is available and the data is written, the response is sent back, and eventually the uh, third node would contain the data, or the primary would write the data into the third node eventually. So if in any case, let's say the user is requesting uh, for that particular item uh, uh, before the data is written into the third node and the request router routed to that third node, then there is a chance that a user might get a stale data. But that is you know that is 1:3 uh, possibility, I could say. So 33% of 30, there is a 33 percent where you could get a stale data. But mostly within that round trips, within a second or within that round trips, the third would be populated as well. But if it is not populated, then there is 33% of chance. So this is a very high level representation of how the data are distributed with the request router. So request router would know where the data to um, route to. So the it would route to the primary node or leader node. The leader node would save the data to different you know secondary nodes. So let's understand a little more in depth of how the table are structured and how the partition works. So as in when you create a table, a hash value will be generated, and hash value will be associated with each item. And based on the hash value, it will be placed on different buckets. In this case, we are imagining that there are three buckets, and the items are placed uh, with these three buckets. And uh, these three buckets again are distributed across different availability zones. So they are highly distributed in nature, and here we are representing just three buckets and three availability zones. But in practicality, the buckets or the partition would be even more when compared to the data or the hash key that is generated. So get item would, as I told, would always give you eventual consistency. You cannot get, there is a 33% chance possibly that you would hit a node, a secondary node, which is not containing the required information. So before it communicates with the uh, storage nodes, it has to go through the authentication system and partition metadata system where the partition metadata system will know the route for or the information about the storage nodes for that particular item. So these storage nodes can be considered as within these storage nodes you would have a number of partitions. This is earlier. So let's understand some of the data structures which are used inside storage nodes. So it would contain mainly two data structure. One is B tree data structure and another one is replication log. So B tree is mainly used to organize these multidimensional records inside the storage, and replication log records the mutation which is happening in the particular partition internally, which means any put or delete or uh, put can be update, create or update can or is logged always within this replication log. So we'll see why we need this replication log to capture every information which has happened in the past. So we have, DynamoDB provides something called as auto admin internally. Of course, this auto admin, the nature and the purpose of this auto admin is it keeps partition metadata up to date. And if there are, let's say, a storage node fails and you want to bring up a new node, then what it does is it would use the B tree and replication logs, and it performs the same operation on on these item B tree and replication log, and it produces the same storage nodes. So basically, auto admin would it can create tables, um, it can provision the read and write capacity, it could split partitions. It's basically DBA for DynamoDB. So let's quickly understand how secondary index are um, created and how they are structured inside the DynamoDB. We have something called as log propagator within the you know within the DynamoDB, where log propagator will keep listening for any update within the base table. So base table has the primary and secondary nodes, one leader node and two secondary nodes. As and when there is an update in the base table or the leader node, a log propagator uh, gets the intimation, and the log propagators are basically uh, are created for secondary indexes. So it would do two operation at the time. So one is delete operation, other one is put operation. So as and when you change the attributes within the item, uh, the index would change as well. So the old index has to be deleted and new index has to be inserted. So if you take an example for five global second, if you have five global secondary index, and if you're changing one attribute of the item, then what happens is 11 different partition gets affected and up to 33 different storage nodes in a single update operation gets affected. So basically that it would be a put operation. For a put operation, 33 different storage nodes will get affected if you have created a five global secondary index. That's the reason global secondary index are expensive in nature. We have got backup and recovery capabilities as well with DynamoDB. So you could create on-demand backups, and it is basically, it creates full backup of your table for a long-term retention. And you have a point in time recovery where you basically, it is used to protect DynamoDB tables from accidental write or delete operations. And this information is stored, or it lasts up to 35 days, and you could recover to any point within 35 days. So there is also another option where you could manually select for uh, say this at this particular hour create a point in time recovery. You can select that, but if you do that, it would be, you would basically be charged for that. There is a mm, reason for that as well, why you be charged, because whenever the snapshots are taken, DynamoDB would decide when the snapshot will be taken for each different partition. So it would be the complete discretion of the DynamoDB underlying uh, subsystems to decide when the snapshot to be taken for each different partitions. But when you say for a specific, when you explicitly mention for a specific point in time recovery, then these snapshot has to be synchronized, all the partition snapshot has to be synchronized and has to be taken at the same time. So you would be charged for those reasons. So let's understand some of the basics of data modeling. As I told earlier, it starts with uh, entity relationship diagram, and you need to define access patterns, how you're going to access the data, and you're going to design your primary key and secondary key indexes before you are before you are constructing the table. So you need to forget your relational experience, like normalizations, joins, and one entity per table. So these are the things you should forget while you are using DynamoDB or NoSQL approach. So I'm going to take an example of e-commerce stores here and quickly run through how we can structure this table. This is a relational table, and how we can convert this to NoSQL or DynamoDB table. Okay, so for this setup, we are going to create e-commerce store, and users are basically making orders, and users have addresses and orders have items. So we'll see how we can construct this in uh, DynamoDB or NoSQL. So we need to identify uh, the first thing that we need to do is like identify the access pattern, right? So uh, access patterns are, first we need to get the user profile whenever we want, right? So we need to get the orders for those users as well. So whenever we say what are the orders available, what are the orders made from for those users, we need to be able to retrieve them. And you need to get single order and order items as well. You need to get orders for users by status and get open orders. So basically open orders is like orders which are still in open state, or which is in some status, and you want to retrieve all those orders. So here if you see the primary and secondary key, we have defined pk and sk because these really doesn't matter. The partition key name, the key itself doesn't matter because it has to be more generic in nature. We are going to use a lot of entities within the primary key, so it has to be generic in nature. So we could use ideally pk and pk for partition key and sk for sort key. If you closely see here, the data are saved in a manner that uh, it has a composite uh, data. It is not just one data or one attribute. It's a composite attribute. We'll see why and how it will help us. And we have to create while doing this exercise, it's best to create an entity chart where we say what are the entities that are there out there, and what would be the primary key and secondary sort key for this chart for the entities. So this is something we're gonna fill uh, by looking at or by revisiting the patterns. So access patterns will we'll see how it goes. So first thing is user has many addresses, right? So we need to denormalize it, and it is basically a document type. So we could say address has homes and addresses. We could use, if it is a document type, we could use something like this, and address are stored as a document inside the user primary key. So user primary key has uh, user ash, the username. So uh, the first prefix user says what kind of entity it is, and the suffix of ash would say what the actual user, what is the username of the user here. And also if you see the um, sort key, it has got profile and the username. So we will get back to that. So basically in this case, in the user case, we are saying this is a profile item. This basically this item refers to user profile. So we have a one-to-many relationship with users and orders. So when you have one-to-many relationship, you got to use it with a sort key. So order would go to the sort key with the order prefix and the order number, and there will be many attributes associated with it. If you see this example, how it's a pseudocode how orders are retrieved. So basically, if you have a user, if you want to retrieve all the orders of the user Alex Debris, what you would do is you would say the primary key is user hash Alex Debris, and uh, it begins with the order hash. So basically, this whole thing has to be constructed from the application end, but uh, that is the trade-off with the NoSQL. So let's say how would we retrieve the items of the which are part of the order, right? So these has items are having one to many relationship, but it is having a one-to-many relationship with with an entity which already has a one-to-many relationship. Hence, this could not be a sort key. So it should be part of the primary key. That's how you determine what has to go with the primary key and what has to go with sort key. So when you're determining the sort key, then if the item already has a one-to-many relationship with another entity, and if that entity also has a one-to-many relationship with another entity, then mostly the entity has to go as part of partition key because it can't be accessed directly. We could achieve this uh, item key, in other way as well. You could add uh, append it as part of sort key as well with an hash, and you could do that. But it would be best for us to place this uh, in partition key because you could retrieve based on items. And we also see why and how we could benefit from this. So there is also, if you notice this, the orders items up, as a sort key is placed in different, uh, as part of different partition key. So orders, the same order is part of user, and this it's also part of item. So if you want to retrieve uh, the user and also the items which are part of the order key, what do you do? So the answer is we would use inverted index. So inverted index are nothing but we would create a global secondary index for uh, the secondary key and the sort key and the partition key. So all the sort key would be the partition key, and partition key would be the sort key. So when you do that, you would get you could retrieve the all the orders, um, sorry, all the entities which are related to that particular order. So by giving the order number, you could retrieve users, you could retrieve items which are belonging to order, and all this happens within just one request. So the benefit of constructing this architecture or hierarchy is within, if you supply one uh, order ID, you could retrieve the details about users and all the items which are part of the order. Now let's see. Okay, I'm sorry. Now let's see uh, if you want a particular, let's say if you want to retrieve the status, if you want to retrieve the items based on status, let's say that. So what would you do? So what you would do is you would create another global secondary index on the status, and uh, you can scan on this. So what happens is you would get a sparse index, because sparse index is because you have a very little number of items which are of those status. So it would be a subset of your table, and you could retrieve the items faster uh, because of small in number. So the key takeaway from the whole of this exercise or NoSQL is avoid. Yeah, sure. Hmm. Yeah, of course, you could do it. Uh-huh. No, it is mainly used for retrieval. Not sure what. So if you want to, yeah. So for put item, right? So put item would you would specify the primary key, right? So sorry, partition key. So there would be no need for index at all. I didn't get that part. So basically, update using order ID. No, you can't do it. So just understand this. Understand something like this. Okay, these are not unique, right? So if you want to update anything, then it has to be item wise. It cannot be, uh, you know, on a bulk thing. So even though you do that, right, it will be internally. It would be inserted one by one. It won't. Mhm. So like what? Can you give me an example here in this? Mhm. What do you want to update here? I just want to that's what it is, right? So if you give order number and if you give item, it wouldn't know which, unless you give this detail, it wouldn't know which one to update, right? So if you give order ID and the, you know, the basically partition key and sort key, only then you can update it. Yeah, of course, you need that. So if so understand like this. So any uh, update or write operation, you if it is a composite key, right? So for composite key, you need to have both partition key and sort key. You cannot just give one key. If you have a simple partition, right? Uh, Only then you could use the then you could update it, right? So if you have a simple partition, then you just need a partition key. If you have a composite, when you have both partition and a sort key, then you need to use both in order to identify the item and then update. Okay. So the takeaways are: avoid normalized data models in NoSQL. NoSQL schema reduces both number and complexities of queries, and NoSQL does not mean non-relational. So we need to understand that there is a relationship built inside the NoSQL. That relation is hierarchical relationship, and the complexities of queries uh, are reduced in terms of retrieval, but complexity lies in constructing the NoSQL um, table itself, and uh, the data within the NoSQL is always denormalized and storage heavy, right? So these are the takeaways from um, takeaways for NoSQL. So that's all I had for today. So if you have any more doubts, we could discuss on that. Otherwise, we could good to go. Okay. Okay then.